Hey guys, so in this video, we are gonna look how you can convert a top-down approach to bottom approach in dynamic programming. So you must have seen a lot of videos about tabulation method where we directly make tables and try to visualize how we can solve dynamic programming problems in bottom-up way. But here we're going to see how you can convert a top-down approach to bottom approach in a much easier fashion. And once you will be able to solve in that way, it will become a lot more easier for you to solve such problems. It will just take 5 minutes to think about it. So let's dive into this and see how we can solve in this way. So, in order to explain this approach, I'm going to take two classical DB problems. The first one is longest common subsequence. So, given two strings, text1 and text2, return the length of their longest common subsequence. If there is no common subsequence, return 0. For example, AC is a subsequence of A, B, C, D, E, right? So, we are going to take first example to understand how we can write the recursive approach. So here we are going to take two pointers I and j, I for text1, j for text2. So the case 1 would be if both the characters are equal, like at I and j index we get equal characters, then in that case what we can do is we can call I plus 1 and j plus 1. Okay, we can just move both the pointers to the next character, right? And since we got the match, we're going to consider 1 also, because this is going to get included in our answer. Case 2 would be where both the characters are not equal. In that case, there will be two possibilities. One would be that we need to move index I to the next character, and the other possibility would be where we are going to move the jth index to the next character, so that we can get all the possibilities and we can check which one is giving us the longest common subsequence, right? So I plus 1j and func of I comma j plus 1. So out of both we will get the maximum. We can just check which one is giving us the maximum, right? So let's start up with the code. Let's write down the code and see how we can solve this. So first we are going to take the length int n comma m is equals to text1 dot size, m is equals to text2 dot size, right? Now we are going to take one variable, longest common sub. This variable will be storing our answer, so we are going to call the recursive function from here, which would be longest common sub finder. We will pass text1, text2 and 0 comma 0. So 0 comma 0 are both the indices which we are going to use in order to compare the characters, right? So in the end we will just return the answer. So this is our recursive function. We are going to define our parameters now. So the base case, first we need to discuss the base case. So base case would be if any of the pointer reaches the end, that means we need to stop the recursion and we need to return 0 in that case, right? So if I is equals to n or j is equals to m, in that case you can just return 0, right? And the cases we discussed, so case 1, if text1 of I is equals to text 2 of j. In that case, we are just going to return text 2 I plus 1 j plus 1. Okay, like we discussed. Simple. Else we are going to take two options as we discussed for the case 2. We are now writing down for the case 2. So first option 1, so the case 1 was where we were moving the index I to the next character, right? And the other one was where we were moving jth index. Just return maximum out of both the options. Right? Simple. So we are done with the recursive approach. Now we need to memoize it, right? So let's memoize it first. Let's define a DP. DP is equals to vector of vector. We are taking 2D vector because there are two parameters that are changing I and j, so yeah, that's why. So we will declare it with -1. So as you already solved these types of problems, you must have the idea how we can do this problem, like write down the basic top-down approach. So we just check that for ij whether it has -1 or not. If it doesn't have -1, so that we can just directly return the value because it's already got computed, right? And we can, for each call we are making, we are just going to store it in our DP for that particular ij combination. So here we are going to take a reference because in the worst case it can give me TLE. The code looks fine to me. Let's check if it is working correctly or not. Let's run it. Yeah, the sample cases are getting accepted. So the solution also got accepted. So the important thing now, how we can change this top-down approach to bottom-up one. How we can do that? Generally, you must have seen in various videos on YouTube that what they are doing is they are using tabulation method and they are trying to fill up the values in a table and trying to explain on the basis of some condition criteria. So that is a bit difficult to grasp. It's like a bit difficult for the beginners and it doesn't give us the practical idea of how the things are working, right? So what we can do is we can just understand the fact that when we are at I and jth index, right, we want the value of I plus 1 or j plus 1 in various cases, right? So we want those values to get calculated. If and only if we have we can get the value of I plus 1 and j plus 1, then only we can be able to return our answer. So that's a dependency, right? So if that is a dependency, how we can already store that value? Like if we want that I plus 1 and j plus 1, can we do something in order to get the value of I plus 1 and j plus 1 like before solving it for I and j, so that we can just call I plus 1 and j plus 1 directly, like the value is already pre-computed, we just need to call it and get the value out of it, and then we can just solve it for ij combination, right? So this is we are going to do in this approach. What we are going to do, let's remove this. to write a for loop. So in recursion, we are starting from the beginning. We are moving from 0th index, right? But in the case of bottom, we already know we move from the bottom. So we are going to start from the end, okay, right? For I, since I was moving from 0 to n, here in this bottom approach, we are going to move it from n to 0. So, and same for j as well. Okay, now we can just directly write down all the cases we discussed. We have written in the top down. So the first one is the base case. If I is equals to n or j is equals to m, in that case we can just store 0. We were returning 0, as you can see here, so we can just directly store 0 in here. Else if the next case would be if text1 of I is equals to text2 of j. So text1 of I equals to text2 of j. In that case, just what we need to do is dp of I j equals to dp of, so what we are doing, we are moving from the end, right? So the values are already pre-computed, we can say, right? So as you can see, we were calling I plus for I plus 1 and j plus 1 combination, so the values are already computed, so we can just use those values like this, right? We don't need to call any recursive function, so it's much simpler. Else the next case would be, there were two options, so we don't have to call two functions here, so we just have to do is dp of I j is equals to max of dp of, first case was where we were calling I plus 1 and j, so I plus 1 and j, and dp of I j plus 1, the next case here, right? So this way we can do this, and in the end, earlier what we were doing, we were just calling for 0, 0, we are calling the recursive function for 0, 0. Now we just have already, we are having the value, so we can just return it, right? So it's that simple, and all the cases are covered now, right? And everything is fine, so we can just run it and check whether the samples are working or not. Samples are working, let's submit it. So it got accepted. So our first example is completed, and now we're going to solve edit distance. It's also a famous problem, and it's a bit on the difficult side, so let's see how we can do this problem. Given two strings, word1 and word2, return the minimum number of operations required to convert word1 to word2. You have the following three operations permitted on a word: insert a character, delete a character, replace a character. So these are the three operations we can do, and so we're going to understand this problem with the example of this one. So let's see. So this is our example. So cases are, the first case would be that we are going to take two pointers I and j. So if I and j character are equal, in that case what we can do, I think we don't need to perform any operations in that case. So we are not going to include, like, we can just move on to the next case. We can just move out both the pointer to the next character and see what we can get as an answer from there. So func of I plus 1, j plus 1, we can just directly call, right? For case 2, there are three options for us in this case. So option 1 would be the operation 1 we are going to perform on word 1, right? So what is operation 1 here? Let's understand. Insert a character. So for example, if I insert a character, for example, I inserted R because J was pointing out to R and I was pointing out to H, so I inserted R before it, right? Like now the pointer is pointing out to R. Okay, so what happened is we got the match. We got the match. But the thing is that effectively ith index didn't change. Since it was at 0, we can just say that it didn't change. Uh, like visually we are inserting a character, not actually. So we got the match, but the index is not going to move to the next, means O character, right? So we are going to keep I index as same, and we are going to move the jth character, the jth index. Okay, so we're going to call func of I j plus 1. So operation 2, it's like delete a character. So for example, if we delete H here, so did we get any match? No. So we moved to the next character and we are still at the same character for word 2. So that means func of I plus 1j. For operation 3, replace a character. So in that case, for example, H was there, so if we replace H with R, that means we got the match and we move both the indices to the next character. So that's convenient, right? So we can just move both the index to the next one. And out of all the options, all three options, we want the minimum one. Like we want to return minimum number of operations. So out of all the options, we will return the minimum. Okay. And let's write down the code first to understand. So again, same thing I'm going to do. I'm going to take the lengths. Word1 dot size m is equals to word dot size. To take the answer, to call min distance finder, which would be a recursive function. Word1, word2. So ij here again will start from the beginning. So 0, 0 I'm going to take, and in the end I'm just going to return the answer. So in this case I'm just directly writing the top down approach, so I will also take the TP here. Since two parameters are going to change for the recursive function, I'm going to take 2D vector. Of n plus 1 size and plus 1 minus 1. So our recursive function min distance finder, we're going to define our parameters here. So the base cases first we need to discuss. So first base case would be if both I and j reaches the end. In that case, obviously we need to return 0. Another case would be if, for example, I reaches the end only, but j is in between. That means some of the characters are left and it didn't get any match. So in word 1, since we are at the end, we need to insert some characters in it, right, in order to get the match in word 2. So we are going to perform m minus j operations, right? Because for example, we are at jth index in word 2 and some characters are required to reach till the end, so that we will get like this m minus j with the difference. Same thing I'm going to do with when, like for example, when the if jth index reaches the end of word 2, that means that we are in the middle somewhere in word 2, so we need to delete the extra characters from the end, right? So return n minus I. Now the case one I discussed, if word 1 of I is equals to word 2 of j, in that case return minimum distance finder word 1 word 2 I plus 1 j plus 1. We're just going to move both the indices, right? And since operation didn't get performed, so we are not going to consider it. Else, so there are three options. Option 1, finder word 1 word 2. The first case was where we were inserting a character. Inserting a character means that, okay, so the case was we were inserting a character. So when we insert character, I doesn't move, j moves, because we got the match. For option 2, word 1 word 2, and since we were deleting a character, basically we are moving ith index but not j. In option 3, since finder word 1 word 2, and in this case we are replacing it, so we got the match. We are going to move both the indices. We are going to return minimum out of all the three and going to add 1 because we performed one operation for each options, right? So I think we are done. Okay, we need to add one case here, which was memoization case. Now if dp of I j is not equals to -1, that means it is pre-computed, then we just need to return the value of it, and we are going to store the value in dp for each of the calls we are making. Simple. Now we can just check whether this particular approach is working or not. Perfectly fine. So we can just submit and check. Working. Now one thing what we can do is we can convert into bottom, which is the important part now. So again the same thing is happening, right? We are at ij, we are looking for I plus 1 and j plus 1 in any of the cases, right? So we want that index value to get computed, right? So what we can do, again for int I, again we are going to take these two changing parameters. So first I is going to begin from the end here, because like that we did in the previous problem as well, right? So I will be moving in this manner. J will be moving also in the same manner. So now what we need to do is we need to take care of all the cases right now. So if I is equals to n and j is equals to m, in that case dp of I j is equals to 0, because we were returning 0 for this case. Else if this case where it was equal, we were returning dp of ij. What we were returning for I equals to m, we were returning m minus j. So m minus j we are going to store. Else if j is equals to m, if it reaches the end of word 2, then in that case we were returning n minus I. Else if the case where word 1 of I was equal to word 2 of j, so in that case Just going to write it normally like this. dp of ij. So the value, since we have already calculated the value for like ahead, that means we can use it now because it is pre-computed now. So dp of I plus 1 we were calling for this case, right? So simple. Else the last case. So we don't need to call like this like 3 times. We just, what we need to do is dp of I j, since the value is already calculated, we just get the value from the dp itself. So minimum of dp of, so I have to check first combination of I comma j plus 1, I comma j plus 1, dp of I plus 1 and j. So I plus 1 j, I plus 1 and j plus 1, the third one. So it's done, and we need to add 1 in it, right? So that, and in the end we can just return dp of 0 and 0 because we called initially for I is equals to 0 and j equals to 0. So the value is calculated already, and now we can use it. I think it looks good. Let's see. We can remove this as well, but let's see. So we can take a reference in case if we can just remove it. So this is the bottom approach. See if the samples are running. Samples are running perfectly. Let's submit it. Got accepted. So this is how you can solve these type of problems, DP problems. Basically every DP problem you can solve with this kind of approach. You just need to do some tweaks in it, and I think you need to think a bit harder for some of the approaches which are like really tough to convert. So that's the way to do it, and I hope you got to know some new things from this video. And thank you for watching, guys. If you like this video, you can subscribe my channel also, and you can add a comment down there if you have any suggestions for me. So thank you, guys. Bye.